All right, today is lesson 4, numbers raised to the 0th power. So just right away, we'll start. I'm going to give you about 30 seconds to think. What do you think 2 to the 0th power is equal to? All right, 30 seconds to think of that. All right, now you have 30 seconds. Go ahead and pause this video and share what you think 2 to the 0th power is equal to. Pause this video, I'll give you a second. All right, so now let's discover what 2 to the 0th power really is equal to. So as we remember before, the large number, that's called our base. The smaller number, that's our exponent. So let's just examine 2 to the x power, 2 to the x. So 2 to the first, we know what that is. That's equal to 2. And what's 2 to the second power? Well, that's just 2 to the first times 2, right? So that's 2 times 2. So that would be 4. And then, so that was times 2. And then now, 2 to the third power, that's 2 times 2 times 2, correct? Or 8. So 2 times 2 times 2 equals 8. And again, 4 is also equal to 2 times 2. And each time here, we're just going times 2 from the last answer. And then 2 to the fourth power is 2 times 2 times 2 times 2, which is also equal to 16. All right, so who can tell me what's happening if we go in the opposite direction? So let me just erase this quick. Let's start here with 16 to 8. So when we go backwards, we're going divided by 2. And back here to 4, that's divided by 2 again. And then 2 to the first power, that's equal to 2. So once again, divided by 2. So now, do you think that this would be divided by 2 as well? What is 2 divided by 2 equal to? That's right, 1. So what we're going to learn now is that any number to the 0th power equals 1. So in this case, x can equal any number greater than or equal to 0. All right, go ahead and find this in your workbook. So when we were multiplying exponents that have the same base, what would we do? We would add the exponents. These two numbers would get added to make this. So let's talk about, that's the first rule. So let's talk about the second rule, the second law here. So x to the m to the n equals x m times n. So we had x to the third, in parentheses, to the second. What would that equal? Well, you take these two numbers and you multiply them, and it equals, what's 3 times 2? 6, right? So it'd be x to the 3 times 2, or x to the 6th power. Alright, and then there's our third law here. X, y to the n equals x to the n, y to the nth power. So why is that? Well, it's because of the distributive property of multiplication. Because this is also x to the y repeated, n times. As you know, with multiplication like this, we can rearrange these to make it this: x times x, n times, and times y, also n times, which gives us this. Alright. Now let's go over example 1 briefly. Exercise 1 in your workbook. And you'll also find that this chart is in your workbook too with the laws of exponents there. Exercise 1. List all possible cases of whole numbers m and n for identity 1. So identity 1 is this identity right here. List all possible cases of whole numbers m and n for identity 1. More precisely, when m is greater than 0 and n is greater than 0. We already know that identity 1 is correct. What are the other possible cases of m and n for which rule 1 is yet to be verified? So you should be thinking in terms of n, m, or n less than 0, greater than 0, equal to 0, things like that. So there will be both. So there'll be m is what to 0, and n is what to 0. There should be 3 different possibilities. So there'll be 3 possibilities like this. So there'll be a greater, in this area, there will be a greater than, less than, or equal to sign going in there to tell me what the possible cases, the possible values of m and n could be for this law. Now that we know that you can take numbers to the 0th power. So go ahead, pause this video, take a moment to think about that, and share your answers with a partner. Alright, now that you've hopefully shared what you think the answer might be, let's go over what this is. So, we're talking about x to the m times x to the n equals x to the m plus n power. So, right now we know that exponents can equal 0, and we know that exponents can be greater than 0, but we don't know about negative exponents yet. So we're just going to assume that the exponents are equal to 0 or greater than 0. So if they are 0, what would that be? That'd be m is equal to 0, n is equal to 0. So that'd be x to the 0 times x to the 0 equals x to the 0. So that's what that would be. We could have m is greater than 0, n is equal to 0. That would be something like x equal to 3 times x equal to 0 equals x equals to 3. X to the 3rd power times x to the 0 power equals x to the 3rd power. And our last one could be m is equal to 0 and n is greater than 0. That'd be something like x to the 0th power times x to the 10th power equals x to the 10th power. Why? Because 0 plus 10 equals 10. So, for exercise 2, you're going to write something out very similar to what I just wrote out. I'll actually do the first one with you here. So for our first one, m equals 0, n equals 0. We know why do we know that's true? Well, x to the 0 times x to the 0 equals x to the 0. And we know that every number to the 0th power goes 1. So we know that all we're saying is 1 times 1 equals 1. And that'd be a true statement. So what are you going to do for the other ones to prove it? That's what you have to do for example 2 now. So go ahead and take a moment, pause this video and take a moment to solve that, or try your best at that. Oh, sorry, I see I made a mistake here. This should be n, my bad. Alright, let's take a look at this next one. So m is greater than 0, n is equal to 0. So our formula is x to the m times x to the n equals x to the m plus n. So our m is greater than 0, so that's just x to the m. But we know n is equal to 0, so then x to the 0. What is that equal to? Well, it's equal to x to the m, because it's m plus 0, which equals m. Anything plus 0 would just equal itself. So that would be x to the m. And it's a similar thing here. For m equals 0, n is greater than 0. That would be x to the 0 times, times x to the n equals, what do we think this equals? X to the n is what that would equal. So for exercise 3, we're going to check case by case. Again, m is greater than 0, n equal to 0, I'll just put that in the other order so it makes more sense. M equal to 0, n greater than 0, and also m equal to 0, n equal to 0. So these 3, how are we going to check these equations? So on all 3 of those. So similar to what we did back here, where we offer a solution like this, or this, we'll be doing for this x to the m. Oh, it's right here. So there, x to the m to the nth power equals what? Following these 3 constraints. Go ahead and try to work that out for me. So you should have 3 different answers. So pause this video and discuss. Alright, hopefully now that you gave it a shot, let's run through these. So let's start with m is greater than 0, n is equal to 0. So x to the m, a number greater than 0, and in this case, n is equal to 0. So what is this equal to? Well, it's equal to x to the m times 0 power. So anything times 0 is 0, right? And we know that anything to the 0 power equals 1. So that is equal to 1. Let's do this one next. M equals 0. N is a number greater than 0. So x to the 0 to the nth power. So what is this going to be now? Well, once again, it is just x to the 0 times n this time. But we still know that is going to equal 0, because anything times 0 equals 0. So that's also equal to 1. Now let's go yellow. How about when they both equal 0? We'll go over here. X to the 0 to the 0th power. Well, that's equal to x to the 0 times 0, which is also known as 0, which is also equal to 1. So every single one of these is equal to 1. So go ahead and pause for a moment, look these over if you need to. I'm going to erase these and we're going to go on to exercise number 4. I think you're catching on to it by now. Okay, for the next one, the third law here, all you have to tell me is, does this work when n equals 0? Go ahead and try to solve that for me. Pause the video if you like. All right, let's try to work through this. So x, y to the nth power, in this case it's 0, is equal to x to the 0 power, y to the 0 power, which is equal to 1 times 1, which is equal to 1. So there we go. Yes, it does work when n equals 0. All right, the next concept in this lesson is exponential notation. So I'm sure you've all heard of base 10 counting. That's where you have the hundred spot, the tens, the ones, the tenths, the hundredths, and the thousandths when you go into the decimals there. But the 100 spot, the 10 spot, and the 1 spot. Well, I'm sure maybe you're wondering, why is it called base 10? Well, remember when we have an exponent, this is called the base, right? Well, with base 10 notation, the exponent tells you how many times the decimal moves, essentially. So if we take 10 times 10 to the third power, well, we go back to that 10, and usually the decimal's right here. That's where it ends. But since it's to the third power, we're going to move that decimal 1, 2, 3 places. So now instead of 10, we have 10,000. Let's try another one. Let's take 3 times 10 to the second power, 10 squared, also known as 10 times 100, or 3 times 100. So we start with our 3, and since our exponent is 2, we move the decimal 1, 2 places. We end up with 300. And this decimal moving only works with base 10. So that's when you have 10 as the base. So we hypothetically took a number like, I'll erase some of this. Okay. The next exercise has something called expanded form. So let's just take let's just say 2,121. Well, the next question asks for this in expanded form. All that means is that we break this down into thousands, hundreds, tens, and ones. So how many thousands do we have here? I'll do a different color. How many thousands do we have here? If you said 2, you'd be right. So that's 2 times 10 to the, wait a second. How many zeros are there in 1,000? Or how many numbers are there after the 2 in the thousands place? That's 1, 2, 3. So that's 10 to the third power. So 2 times 10 to the third power is equal to 2,000. So that's our thousands place. So what was that? 121. 2,121. Next, let's look at our hundreds place. How many hundreds do we have? Well, we only have 100. So 1 times 10 to the, well, how many zeros are there in 100? How many numbers come after the 1 for 100? That would be 1, 2. So 10 squared. Now, we're going to go to, I'll erase this again. There we go. Sorry. Now let's go to the, I should put a plus sign here. Let's go to the 10 spot. So how many tens do we have in this number? 2, that's right. So it'd be 2 times 10 to the, how many zeros are there after 10, or how many zeros are there in 10? That's right, 1. So our exponent is 1. What is 10 to the first power also known as? If you said 10, you would be correct. All right, then our last one is the 1 spot. How many ones are there? 1 times 10 to the, what do you think is next? What intuitively seems like it should be next? I should also do this in a different color. You said 0 power. You are correct. So our final answer would look like this. I'll write it in normal color. 2 times 10 to the third plus 1 times 10 squared plus 2 times 10 to the first power plus 1 times 10 to the 0th power. And then 1 times 10 to the 0th power would also be known as 1 times 1. 10 to the 0th power would be 1, because any number to the 0th power equals 1. Alright, so this is just a really fancy expanded way of saying 2,121. So when they're talking about expanded form, this is what they're talking about. I'll do one more just for practice. I already saw this. Sorry, it's taking me a second to erase. Alright, let's choose a really boring, normal number, like 1,392. Alright, so let's break this down. We got our thousandth place, hundreds place, tens place, and our ones place. So let's go ahead and first of all get the thousands place. How many thousands are there here? Well, there's not quite 2. How many full thousands are there here? 1. Then we take it times 10 to the, how many zeros are there in 1,000? So how many numbers are there after the thousandth place? 1, 2, 3. So we have 10 to the third power. Alright, simple enough. Plus, so this is our thousands. Next, let's do our hundreds. How many hundreds do we have? Well, it's almost 400, but it's not quite 400. So what is it? 300. So 3 times 10 to the, how many zeros are there in 100? 1, 2. So this is just a fancy way of saying 300. 300, 1,000. Let's do our tens place. How many tens do we have? Right here. 9 in the tens place. So 9 times, how many zeros are there in 10? That's right, 1. So it's 10 to the first power. And we know that any number to the first power is itself, so it'd be 9 times 10, which is also known as 90. Plus 2, because that's all that's left over now in the 1 spot, times 10 to the 0 power. And any number to the 0 power is 1. So 2 times 10 to the 0 power is also just known as 2. So this is a fancy way of saying 1,000 plus 300 plus 90 plus 2. And if you did this arithmetic or ran it out in a calculator, you would get 1,392. So this is called expanded form. This is what they're going to be asking for in the next 2 problems. So now that we've done 2 as a group, or that I've modeled 2, go ahead and try exercise 5 on your own. Alright, let's try this together, now that hopefully you've tried it on your own. So what do we have in our thousands place? 8,000, that's right. So 8 times 10 to the, how many zeros are there in 1,000? That's right, 3. Plus, now what number is in our hundreds place? If you said 3, you'd be correct. Times 10 to the, how many zeros are there in 100? Times 10 to the second power. Plus Now it's in our tens place. What number is in our tens place? 70, so that would be 7 times 10 to the first power. And finally, we end up back in the ones place with 4 times 10 to the 0 power. And once again, 10 to the 0 power is just 1. So you're saying 4 times 1, which is just equal to 4. All right. Go ahead and try exercise 6 on your own, and we'll come back here and complete that one as a group as well. So go ahead and pause the video. All right, let's keep in mind, this is called expanded form. So this one's a little different because it's not to the one, it's not a 1,000 number, 8,000, it's 6 million. So now we had to count how many numbers there were behind 6 million. So let's go ahead and do that. So we start off, look at this, the largest number here, or the first number, I mean. So 6. And what spot is that in? That's in the millions spot. So that's 6 times 10 to the... How many zeros are there? Well, I can just group them together and see that there are 6 spots after the 6 million. So I know that there's 6 zeros in 6 million. So that'd be 6 times 10 to the 6th power is 6 million. Plus, what is our next? Now, our next number is 900,000. So I'm sure most of you can see a pattern starting to form here. Our next number is 80,000 times 10 to the 4th. And then 5,000 is our next number times 10 to the 3rd. And then we have a 0 in the 100 spots. So that'd be plus 0 times 10 to the 2nd, and then I'm going to run over here, so I got to come back down here. Then we're looking at a 6 in the 10 spot times 10 to the 1st, and then we are looking at a 2 in the 1 spot. So again, this is a fancy way of saying 6 million plus 900,000 plus 80,000 plus 5,000. Oops, sorry. Plus 5,000, plus 0, I guess, plus 60 plus 2. All right, I hope you all understood that fine. You will find on Google Classroom, I took screenshots of the exit ticket and the problem set and selected the ones I wanted you to solve. You will be able to find those on Google Classroom. Call under the title Friday, September 18th, exit ticket. So go ahead and do that work in your book and then select the correct multiple choice answer on Classroom. So go ahead and do that. That should be all. This should take up the whole class time today, so thank you.